right, well, today we're not talking about caching. I think I mentioned caching once, but we're going beyond that. We're talking about best practices for scaling your Rails application. Hannah gave me a great intro, so I'm not going to say that much more about myself. I'm based in Colorado. I work at GitHub, but I don't work on the deploys team anymore, so I'm sorry. My bio is old and not updated. I moved to the GitHub Copilot team, and we actually just, what happened to my image? We just released something called Padawan that I was working on, where you literally assign Copilot to an issue and it writes all the code for you and tags you in a pull request. So that's what I've been working on now. But yeah, VP of Ruby Central, we're doing our last Rails Conf this year in Philadelphia. So if you want to come out to the United States, I know not a lot of people want to do that right now, but it's the last Rails Conf, so we would love to have you in Philadelphia. We want to support more conferences like this globally moving forward, so would love to talk with people about that as well. All right, we'll get into it now. I'm going to tell you a story. It is 4:59 p.m. on a Friday. You push the last deploy of the week, and suddenly everything slows to a crawl. Customers start complaining, logs explode, your Slack is going off, pagerduty is pinging you every 2 minutes. What happened? You hit a scaling wall because caching alone wasn't enough. A coworker of mine, of course, makes like a snide comment that Rails does not scale. Raise your hand if you've ever heard this before, that Rails doesn't scale. Yeah, I feel like that's a really known thing, people saying that. But actually it does. A lot of big companies with massive scale rely heavily on Rails. GitHub being one of them. GitHub, this is the number of requests that github.com handles per day, which is crazy. Over 1 billion requests. And 24 million requests per minute. So obviously, Rails does scale. Most of our infrastructure is in Rails. So before working at GitHub, I used to think, hey, we just need to memoize this, and that means we can scale. Caching was the only thing that I thought of when I heard of the word scale. And don't get me wrong, I think caching is great, but there's so much more to it. So here today, I'm going to talk to you about some other things that you might not think of when it comes to scaling. A lot of these I've learned from working at GitHub for the last 4 years, given that traffic that we saw. So we're going to talk about 6 other strategies in scaling your Rails app: segregating data, external dependencies, database and job maintenance, leveraging gems, and monitoring and incident response. This is a lot of information, obviously. So my goal for you today is to walk away with one thing that you're going to implement on your team. There's a lot of different levels of experience in this room, a lot of different companies, a lot of different teams, a lot of different code bases. So we're really going to focus on breadth because I'm hoping that you're going to find one thing that you're not doing that you're like, wow, I'm totally going to implement this and bring this to my team. So first, we're going to start with segregating data. So one way you can do that is by using S3 to serve and store static assets versus storing them in a relational database. Is anyone doing that already right now? A couple people. Okay, so even if you are, regularly doing an audit of your code base to see if there's anything that you could be storing in S3 versus your database, you can configure the AWS SDK S3 gem pretty simply. As you can see here, this is just a little snippet here. It's pretty easy to get up and running, some config steps. You can read a blog post about it, ask Copilot, and you'll be able to use S3 to serve these static assets. And everything is scalable, cacheable, and Rails native, which is nice. Another thing I want to talk about is the active record pattern in Rails. It's really convenient, it's commonly used, but as Rails apps grow, it can introduce real problems for scalability, performance, and maintainability because simply data is not segregated correctly. Active record inherently combines persistence logic with business logic, making it really tough. And this is fine at a small scale, like if you're a startup, you just want to get an MVP out the door, but as you scale, it becomes very problematic. So many Rails applications start by putting business logic from the get-go inside active record models, which follows the classic OOP approach. However, this leads often to God classes, where we have models like user or insurance policy, and they become unwieldy and difficult to maintain. How many people here, raise your hand if you work in a code base that has more than 100 lines of code? Okay, see, a lot of hands. Pretty much everyone's hands went up. So we can prevent this by exploring other patterns. Instead of directly thinking, okay, I'm going to do this, I'm going to do what I've always done in Rails, we can think about other ways of how we approach this. One of those is called the transactional pattern. You've probably seen this before, maybe not put a name to it. So in the transactional pattern, models are just data representation with database access. You have services that it's their job to handle the business logic. And controllers and jobs are just the thin wrappers around these services. So instead of logic and data being tightly coupled, we have this really nice segregation. And here I'm going to show a basic code example of like the difference between like the active record pattern and the transactional pattern. So here we have business logic inside an active record model. We're just updating the Copilot subscription here. And this can lead to tight coupling between the data layer and business logic. In this code example, this is the exact same logic, but we use a service object. This really minor change to the architecture can make a really big difference when it comes to scale. So even if you're in a smaller team, a smaller company, maybe think about approaching it like this first instead of the first way that I showed here. So don't get me wrong, I'm not here to like just talk crap about active record all day. You know, it's great for getting started, you know, CRUD-heavy apps and simple domains. But for large-scale apps, it really does create performance bottlenecks, architecture drift, maintenance headaches, and spaghetti code, which I'm sure all of you have been in, and it's an absolute nightmare. So once you're in a place that is really hard to get out of this too, if you're just so coupled to this pattern everywhere. But there's also a really fine balance between optimizing too early and being stuck in the past with decisions that you've made without thinking about it. So I think a really big trick is to know when to step outside of active record and treat it as a persistence tool and not your application layer. So this is a really good, topic of discussion to bring up on your team. Are you ready to start moving in this direction and win? All right, a couple other things to watch out for that we use all the time as Rails developers are instance variables and stateful classes. So backend architectures are typically designed to be horizontally scalable, meaning any application instance should be able to handle any incoming request. This only works reliably if each instance is stateless though, with no memory of past interactions or stored internal state between requests. So instance variables inherently are anti-horizontal scaling, because they do. So we can apply functional programming principles to Ruby to object-oriented systems. These stateless designs are a functional programming principle, and they avoid internal state, like instance variables. So any function or method's output depends solely on its input. Business logic should be implemented in stateless modules. It's self-contained, and it only works with what it's given. These methods don't rely on instance variables or persistent state inside an object. Instead, they just get data from the database, do what they need to do, perform their logic, what you tell them to do, and return a result. And this pattern ensures that it can be distributed across many servers without coordination or shared memory. And really, this is essential for scalability and testing. So TLDR, I just talked a lot on this, is large Rails apps slow down when business logic lives in models. And separating data from logic leads to faster, more maintainable code bases. And using service objects and transaction scripts allows for horizontal scalability, which we really want. And stateless code avoids memory bottlenecks and makes debugging simpler. This approach really makes sure that your Rails applications are future-proof and makes scaling a lot easier instead of when you're getting paged at 4:59 at night and oh crap, like I'm not gonna have a weekend anymore. All right, so moving on to external dependencies. We have external dependencies, we all need them, but they also have to handle your application's load too. So they're also dealing with scale, except you have no control over it. So you wanna make sure that you're aware of all of your external dependencies. Something that we like to do at GitHub are called BCDR exercises. Has anyone done a BCDR exercise? Oh, okay, cool, this is new. So basically, business continuity, wow, I can't say that word, and disaster recovery is what it stands for. They're absolutely critical for scaling. So what you do is you basically make a big list of all of the external dependencies that your app has. So, and as your app scales, more users depend on it, right? More data flows through it, more revenue is tied to it. So if even an external dependency goes down and your system goes down, that blast radius is huge. So these BCDR exercises prepare you for when something goes wrong, which it will, or one of your external dependencies goes down. So this drills into, what dependencies you have, making sure you don't have any blind spots, and making sure that you have a failover plan for when one of your external dependencies fails. It shows you what weaknesses you have. So they force your team to answer questions like, can we recover from a region outage? What happens if our primary database is corrupted? How do we fail over our background jobs? So just making sure that you're prepared when that time comes, when one of your external dependencies fails. True scalability means handling degradation and recovering quickly without losing data or trust. A system that handles 100 times the load but can't recover from a failure is not scalable. It's really just fragile. So it's also essential that you have these fail-back strategies. You can have early failure detection so that you can put things into place when things start to go wrong. You also want to gracefully degrade so that only certain parts of your site go down instead of the whole thing coming down. Also, just having secondary options, like can you shift traffic in batches or by region? Do you use blue, green, or mirror environments? Those are essential for having a scalable application. Also, be constantly questioning in these BCDR exercises, do you really need this external dependency? You want to minimize them as much as possible since you have zero control over them. So TLDR, regular BCDR exercise on your team, and written out failback playbooks and a codified plan for when things do go down, because they will. We all know that. All right, moving on to database and job maintenance. So back to me questioning active record. Really any ORM. I promise I really do like active record, but it can also generate inefficient queries that impact database performance. So be proactive. Don't assume queries are optimal just because the ORM generates them. We really want to make sure that you're monitoring your slow query logs. If you don't have a slow query log, you should definitely get one of those. And then after each major integration, go check these dashboards. Make sure that there's no slow query that popped up here or there, and if so, really prioritize getting those fixed. Also, you want to look for missing indices. That's a big thing, indexing things. But indexes speed up reads, but they actually slow down writes. So make sure you're only maintaining the necessary ones. When I first started at GitHub, I was like, okay, we're going to put an index on everything. This is great, scale. But no, it ended up slowing things down more. So only put indexes where you need them, not on every query. You also want to regularly scrub your database to remove any unused indices that you're not using. And inefficient queries as well, like full table scans caused by missing where clauses. You want to be aware of those as well. So you also want to avoid find all queries. .all, .each, we use those a ton, and I find myself doing that a lot. But I have to be aware that, oh wait, this table size is massive, and I can't just do that anymore. I can't just use .each. I have to use find each. I have to use different things. So make sure that you're using methods, which we have in Rails, that do batching, that do pagination, and limits as well. Only time I'm going to mention caching. Where can you be caching these database calls? Rails has built-in cache invalidation built in to help, which is really helpful. But that's the only thing I'm going to say about caching, and go quickly through that. And then background jobs. Background jobs are also a big liability when it comes to scaling. They can hog resources, especially as traffic increases. So some common red flags to look for your background jobs are jobs that start overlapping, or daily job processing that takes more than 24 hours. That's kind of a red flag to start looking at those things. And you can prevent this by separating concerns. So you want to segregate your background jobs into a separate worker tier to prevent them from affecting your other requests. You also might want to think about prioritizing jobs into different queues. So like a critical queue, default, low priority queue. We also have tooling. We have a lot of really nice things that help us do this, like Sidekick, Rescue, Kafka, these different things. They handle, rate limiting and fault and different things like that are already built in, so making sure you're using one of those as you scale. So the final takeaways here are ORMs, they really do make life easier, but performance and monitoring and optimization are still needed for those. We don't want them to get out of hand to, again, where you're getting paged at 5 p.m. on a Friday. Slow query logs and job monitoring and database audits should be a regular part of your maintenance. Whether you have like an on-call first responder, these different things should be on there where they're going through these, making sure that everything looks good, you don't have indexes that you don't need, your jobs aren't starting to slow down, things like that. Because planning for scale earlier, it's easier to prevent these performance issues than when you're having to do it late night on call in production. So I'm also going to mention a couple of gems because it wouldn't be a Rails talk without me mentioning a gem, but they can also be really helpful for scaling applications as well. One of those is Sorbet. I love their logo. Shopify Sorbet. It basically adds gradual static typing to Ruby. You can annotate methods with expected input and output types and catch errors before you push to production, before runtime. So here I just wanted to show a couple quick examples. The top code snippet is without Sorbet. No static checks, no clarity on types, and it's really hard to catch bugs early. The second one here, you get all this out of the box with Sorbet. Who here uses Sorbet? Do people use Sorbet regularly? A couple hands, okay. So yeah, and honestly, it has caught a lot of bugs for me just the other day. Caught a bug for me before going to production, and I was very thankful that I had it. So why do you use Sorbet for scaling? It is self-documenting, so it's a lot easier to see how methods are meant to be used. It also, like I said, catches bugs before runtime type checking. It's great. A lot of other languages use it. Ruby doesn't, and yeah, it's really nice for catching bugs. It also enables safe refactorings. At GitHub, I can change one little line of code here, and I end up breaking like 100 things over here, and I would have no idea if I didn't have Sorbet. It's also easier to support more engineers because scale means adding more engineers to the team, and it provides more safeguards where, junior developers can come in and get their hands dirty sooner. The second gem I want to mention today is AASM. Has anyone heard of this gem? Okay, so a little more familiar with AASM. It lets you define state machines for models. So I'll go quickly through this. Here we have a code snippet without using the AASM gem for managing state. Yes, this is easier to debug. It is less strict, but any value can be assigned as its state. And then here is the code snippet where you are using the AASM gem. You can see here. You have a lot more guardrails, and you can hook into transitions to trigger audits and notifications, which are essential at scale. So that's just an example of AASM there, but it looks like a lot of folks already use it. I really like it. Encapsulates logic. Business rules are clean and explicit, reduces edge case bugs again like Sorbet, improves the readability as well too. It also helps with concurrency, which is a lot of times a big debate in the Ruby community. It can clearly help define state transitions to avoid race conditions in background jobs or in multi-threaded environments, which are essential at scale as well. So yeah, TLDR, you should try out these gems if you aren't already to help you scale. All right, monitoring and incident response. And I think this is where we start to get into things that you don't necessarily think of with scaling. But you can scale traffic, but if you can't see what's happening or respond quickly to failure, you're just flying blind. Again, these systems are just fragile. So what are some best practices when it comes to monitoring? Are you, read through these things, look at these things. Are you doing all of these on your team? Are you monitoring what matters? Don't just collect metrics. Are you doing latency, error rate, throughput, saturation? Also, tying metrics to business impact. We've started doing that. Instead of like the CPU is at 85%, I like to see can users sign in? I think it's also helpful to have those type of business impacts tied into your monitoring. Add context. This is a really big one for us at GitHub. We do a lot of work to add request IDs and correlation IDs because we have like 8 different ways to see what's going wrong. And if we don't have one correlation ID, it's impossible. So if you start doing that from day one, it makes things a lot easier, especially debugging. Tuning. We just released our new Copilot product, and I was getting paged 7 times a day only because we only had 1 or 2 users hitting 500s because we hadn't released it yet. So I had to create a composite monitor and different things like that. So just make sure that you're actively tuning these alerts because you don't want to get paged if nothing's really wrong. So that's a big thing to watch out for. Because incident response truly is a scaling tool. Every incident is a signal or a chance to find the edges of your architecture. Also, playbooks are essential. This gives folks a clear idea what to do when things go wrong, eliminates the guesswork. Again, you want your system to be up as you scale, right? A lot more pressure, a lot lower stress for responders as well. And can you confidently say that on your team you have a playbook for everything that could go wrong? Probably not. So that's definitely something, a goal to get to. And on-call culture matters. Like this can be really big source of burnout for us, right? So make sure if you're on call, have enough people on your team to be able to do that. Instead of like 2 people, can you add more people to the team? Or other folks on other teams willing to be on your on-call? Also follow the sun rotation. That's been a big thing for us, so I don't get paged in the middle of the night. Having folks who are in the EU here and that sort of thing so that we can share the load. Also, make it a thing on your team. If you get paged the day before and you're up all night working on a bug, you should definitely take the next day off. Make that a known thing. Once one person starts doing it, then more people feel more comfortable doing that. And always follow up with an action item when someone gets paged and prioritize that for the future. That was one thing that drove me nuts about working on my team is that, yes, we'd be paged, and then we wouldn't prioritize fixing the thing that, made me stay up all night. So make sure you're doing that. So TLDR, make sure that incident response is a first-class citizen on your team. Have retros about it. Bring it up. Follow monitoring best practices and observability systems and be able to recover quickly because that's a big part of scale. All right, team dynamics, our final topic. We're almost there, and definitely I don't think is thought of when we think about scaling. It's a team sport. You don't scale a system with code alone. You scale it through a shared understanding, ownership, and collaboration. And cross-functional coordination becomes critical as systems become bigger and more complex. So if everyone on the team has a different idea of how your system works, again, you end up with fragile scaling and something you can't recover from when it goes down. So do you have lunch and learns on your team? This is something we do to make sure we have a shared mental model. Documentation, we've already been talking about playbooks. Pairing, I know a lot of teams don't have the bandwidth to do this, but even if it's just for like an hour a week to make sure everything's on the same page, that can be a really big win too. Also, space to learn, day of learning, different things like that. I know companies do different things there, but maybe that's something you can suggest. Psychological safety. When something breaks under load, people need to speak up, ask questions, and admit when they're wrong or uncertain about things. And team with strong communication and low blame cultures can resolve incidents quicker and learn from them quicker. Also, scaling is iterative, and so are teams. So making sure you're doing those things like retros, one-on-ones, postmortems are really important when things do go wrong. And again, keeping it blameless. Because you can't build a scalable system without scalable teams. Okay, I just threw a ton of information at you and just want to go back to our original goal here. So I'm hoping that you were inspired by something I said here that you're not doing on your team that you want to. I pulled some bullet points from the GitHub Senior Career Track, and a lot of them are kind of tied to things that I'm suggesting, so just want to say those here. So, recommends product or process improvements based on areas of responsibility. So is there something on your team that you can come back with and say, hey, this is cool? Improving team functions, drive improvements in engineering practices and systems is another one. The ability to lead discussions that result in actionable items or decisions being made. Leading by example, culture of psychological safety, and understands and builds for scale, working with system maintainability and long-term goals in mind. So that's, hopefully you pick something out of there that you can come back to your team with and do some of these things that, for example, a GitHub looks for in a senior engineer. But more importantly, I hope that you're not getting paged at 4:59 on a Friday and you're either Netflix and chilling or out. And yeah, that was what I wanted to say about scaling and what I've learned at GitHub. So thank you so much for having me.